Our next case to consider with permutation. So we've got n objects, but now some of those objects are the same. How's that going to change what we do? Okay, let's build it up and try and work out a pattern. Start with the most basic. Well, I suppose the most basic would be one object, but that's a bit boring. Two objects. So if they were all different, we know we could have A and B or B and A. We said, oh, well, that's 2 factorial equals 2. But what happens if the object's the same? Well, if they're both A's, there's really now only one way to arrange, because AA, if I swap them around, it's still AA. The question is, how do I get from 2 to 1? Okay, I could subtract 1, I could divide by 2. There's lots of ways I can get from 2 to 1. Let's look at 3 objects again. Let's see if we can see a pattern. So if they were all different, A, B and C, and all the different ways I could arrange A, B and C, we said, oh, that's 3 factorial. There's 6 ways. Well, what happens if 2 of them are the same? So let's say I have 2 A's and 1 B. Then now there's only 3 ways of doing it. So how do I get from 6 to 3? Well, back when I had 2 objects, I said, how do I get from 2 to 1? So I could subtract 1. Well, clearly that's not going to work for this one. I could divide by 2. Well, that seems to work for this one as well. If all 3 were the same, I'm now down to 1. So how did I get from 6 to 3 to 1? Okay, let's look at 4 objects. Well, that's quite a few if we have 4 objects. In fact, there's 24 of them. If I make 2 of them the same, it's now down to 12. So again, I've divided by 2. It seems to be that's the pattern. If 2 of them are the same, I'll divide by 2. 3 of them the same, I've now gone from 12 to 4. In the last one, I went from 3 to 1. Hang on. There's a pattern there too. I've divided by 3. If all 4 are the same, I've got 1. How do I go from 4 to 1? So more to the point, I'm not dividing by 2, then dividing that by 3 and so on. What I'm actually doing is dividing the total number of ranges by x factorial, if I've got x of them the same. Because what we're really saying is, hey, if they were all different, I know there's going to be n factorial ways of arranging them. But some of these are the same. And if they're the same, then the actual arrangement doesn't matter, because all of those arrangements look the same. So I divide by the number of ways I could arrange those same objects, because I'm not interested in that. They look the same. Connaughton, surname of a student I taught, well, many years ago now, but I liked it because there were lots of different letters in there I could play with. Now, how many different words could we form with this? Well, be 11 factorial, but divided by, I've got 2 O's. I'll divide by the arrangements of those 2 O's, 2 factorial. And I've got 3 N's. So I'll also divide by 3 factorial, the ways I could arrange those 3 N's. And I end up with a lot of possibilities there. Here's an extension one. And yes, they let us know every piece of information. They don't assume anything. In case you didn't know, the letters A, E, I, O and U are what we call vowels. Yeah, I know, amazing but true. How many arrangements of the letters in the word algebraic are possible? Well, there are 9 letters in the word algebraic, but we have 2 A's. There are no other repetitions there. So there we go. That's how many words we could form. Here's why they defined the word vowels, because they now use the word in this question. How many arrangements of the letters in the word algebraic are possible if the vowels must occupy the 2nd, the 3rd, the 5th and the 8th spot? Well, we look after the condition first. The vowels have to go in these specific spots. So let's arrange the vowels. There are 4 vowels. They're going to go into these 4 spots. So no different if I just said, oh, let's arrange the 4 vowels. But 2 of them are the same. I've got 2A. So I'll divide that by 2 factorial. Now, oh, watch out, I'm now going to introduce another definition here that'll blow your mind. Let's arrange the consonants. 5 factorial, the ways of placing the consonants. 1,440. 14D then, let's play with this idea.